let's do some more probability examples for, I think, what is this, 9.7c, if I get this right. Yes, it is 9.7c. So let's say you are given a set of numbers, and there are 4 numbers. So we are given 4 numbers, and you have to guess all of them correctly in order to win a prize. Well, let's think about that first. The very first one, there's 4 numbers. That means you have to get 1 out of 4. There's a 1 out of 4 chance that you will guess that correctly, right? And then the second one, you already guessed that number correctly. There's only 3 numbers left to guess. So the second one, it is 1 out of 3 chance. And then, as you can tell, then the third one is 1 out of 2 chance. And then the last one, there's only 1 number. There's only 1 chance. You can guess that. So the probability on guessing all 4 numbers right would be, multiply all that out. 4 times 3 times 2. It is 1 out of 24 that you will guess all 4 numbers correctly. So let's say you kind of have an inkling, right? You kind of have an inkling and you already know one of the numbers. So let's X out one of the numbers. What is the chance on you winning now? Well, if you already know one of the numbers, you only have to guess 3 more. Well, then the next one, you only have 1/3, 1 out of 3 to guess to get that right. And then the next one, you have 1 out of 2, and the last one is always going to be a chance of 1. So you actually have a 1 in 6 chance of winning. Okay. Let's go try some other things. Let me delete this here. You don't need that. Let's say we have a deck of cards, right? Maybe a deck of cards. What is the probability that we have? First things first, if you don't know anything about a deck of cards have 52 cards. There are 13 of each type. And they are color coded. So the hearts are red. The spades are black. The diamonds are red. And the clubs are black. Just so you know a little bit about info if you've never ever been exposed to a deck of cards before. So and it goes through 1 through 13. The assumption is the jack and the queen and the king are not number cards. So it's 1 through 10, jack, queen, king. So what is the probability of us picking an even number card, right? So let's say we want an even number. With each deck, there's going to be a 1 through 10. And within 1 through 10, there are 5 even numbers, right? There's 5 even numbers here because we have 2, 4, 6, 8, and 10. So there's 5 here, 5 here, 5 here, 5 here. So out of this, 5 out of 13 are gonna be even out of the 52 cards. I mean, you could add up all the 5s out of 52, but it will reduce to 5 out of 15 because if you did 5 out of 20 out of 52, it reduced to 5 out of 13, just like that. What is the probability that we will just get, let's say, one suit, let's say a diamond? Well, there are 13 cards. There are 4 decks. So it's a 1/4 that will get just a diamond. And so forth. let's try another different type of example. So let's say we have a space vehicle. Let's say we have a space vehicle, and that space vehicle has a probability of 0.981 in which the communication networks works, right? It works. The probability that the communication network that it has work, and the communication system. And it wants to ask, what is the probability that during a flight that both systems function satisfactory? So meaning it works. When we say both systems, I'm going to assume two systems. So that means I want the probability of two systems, right? Probability of two systems working. Well, the probability of one working is 0.981. So for probability of two of them, you got to remember multiply our probabilities. So 0.981, so the 98.1% times a 981%. This should give me a 0.96. We want to round it to, let's say, what do they want? They want 4 decimal places, 6 to 4, a probability of both systems working. Well, then, if that's the probability of both systems working, what is the probability of both systems fail? Probability of 2 fails. Well, we need to multiply the probability of 1 failing, the probability of fail, let's say P of fail, is going to be 1 minus 0.981, right? 100% minus that. So that is 1 minus 0.981. That gives us a 0.019 chance of fail. So then we just got to multiply that both times. Our number comes out to be here. We want to round this to 4 decimal places, so 0.0004. So that is the probability. It's actually a very low one that both systems will fail. It's actually a higher probability that 1 will fail than 2 will actually fail. And then finally, the last question is, what is the probability that during the given flight, at least one system functions satisfactorily? So if you think about this logically, that means none of the systems will fail. At least one of them will work. So what we think about this, we have 100%, and then if both of them fails, right? So if both of them fails, that's the worst case scenario. It'd be 0.02. So we want to take that, subtract from the P2 fails. We can have one fail, but we can't have both of them fail in this scenario of at least one working. So we want to take 100%, subtract the one possibility of which both of them failing, which will be 1 minus 0.0004, should give us 0.9996. And that is the probability of at least one of the engines working.